Hello, today we are going to explain what is harmonic motion. Harmonic motion is repetitive movement through a central point where the maximum displacement on one side of the central point is equal to the opposite side's displacement. The time between each interval is the same, which is the frequency. The formula that we are going to be using for our model is f of x equals a times sine times parentheses b of x minus c in parentheses plus d. There are four main parts to this formula: a, b, c, and d. A is the amplitude, which is the displacement from the central point. B controls the endpoint, which is where the model ends, and c controls the phase shift, which is where the model begins. Here is an example of what harmonic motion looks like. In this video, you can see me running from the middle palm tree to the right palm tree, back to the left, and back to the middle. This is harmonic motion. The time it took for me to do that was 12.32 seconds. That is our endpoint for this model. The steps it took for me to reach each critical point is 7. That is our amplitude. To find our b, we have the equation 2 pi over b equals 12.32. Multiply both sides by b, and we have 2 pi equals 12.32b. Then divide both sides by 12.32, and that gives us our b. Our start point and horizontal line are both 0 because we begin at 0 seconds and on our central point. Next, we plug in our a, b, c, and d into our formula. That gives us f of x equals 7 times sine times parentheses 2 pi over 12.32 x minus 0 in parentheses plus 0. Now, we can simplify that into f of x equals 7 times sine times parentheses 2 pi over 12.32 times x. And that gives us this graph here. Another piece of information that is helpful is how to convert data points into a trigonometric model. Simply graph your coordinate points on a plane and use the math that was shown in this video to determine your formula.
Another example of harmonic motion is playing guitar. The strings of the guitar move at a frequency where they start to create sound waves. When force is applied to the strings, they start to vibrate, which creates a symmetrical motion. As the string starts to vibrate, it moves around a center point, very similar to the sunrise and sunset graph. Right here it can be seen how the string moves at a center point and at a symmetrical motion. When this information is graphed, the line graph is very similar to the sunrise and sunset graph because they are both examples of harmonic motion.